Hello students, welcome to my channel AtomiQ. Today I am going to prepare Grignard reagent. When alkyl halide reacted with magnesium metal in presence of dry ether, we get a Grignard's reagent in which magnesium is introduced between R and X. So this is the first one. Now here we are using dry ether. Dry ether. Why? Reason number one. First, ether is a non-protic solvent. Second, lone pair of electrons present on the oxygen in ether coordinate with magnesium metal and forms a complex compound and help from decomposition. Here the stable complex is formed. How? Here this is a Grignard reagent. Two molecules of ether, say an example R2O, I will take like this R2O, right? It coordinates, and in this way it coordinates, that forms a complex compound, and this complex is a stable complex. This complex is a stable complex. In presence of protic solvents like water, alcohol, Grignard reagent decomposes. That's why dry ether is best solvent to prepare Grignard reagent. This is the most important point to be remembered for board exams as well as your entrance examinations. Now we will consider one by one. First one is the preparation of alkanes from Grignard reagent. Simply, nothing to do, simply whenever a protic solvent reacted with a Grignard reagent. What are those protic solvents? Like water, like alcohol, like ammonia, simply the product is nothing but RH. That is alkane group. Right? And what are the byproducts you can write? MgXOH. That means simply, for example, I am giving a simple trick how to do this one. Okay. For water, simply split water like this and make this is one and this is one compound. That means you will get RH plus MgX and OH. Like this you can do all, but simply remember the trick. Whenever alcohol reacted with a protic solvents like this one, then the byproduct is always alkane. Right students? Second, preparation of preparation of higher alkanes. Higher alkanes. This is very simple. When a Grignard reagent, I am writing like this. Whenever treated with a alkyl halide, always we get R prime plus MgX2. Example, RMgBr plus CH3. Let us take here, I am taking CH3 instead of R. CH3 CH2Br. Then what is the byproduct? Nothing. You just remove the Grignard magnesium bromine and here bromine. Simply put your alkane. Alkane means here is one alkyl group. Add this one and this one. So you get the alkane. That is propane. Right, students? What you have to do is in the preparation of higher alkane, simply join. Always remember, when a Grignard reagent react with any other compounds, it always supply one alkyl group. So here the thing is R and join with another R. That means, so in this case, join of alkyl groups to form bigger alkyl. This is the simple trick. What is the trick? That remove this R and join with this R. That's all. Right, students? Now, preparation of alkenes. Preparation of alkenes. When alkyl halide like this, when react with 1 gram equivalent of magnesium in dry ether, then we get Grignard reagent like this is the Grignard's reagent. This is the Grignard. This further gives us as a now this gives a alkane. This gives a alkane. In another way also we can directly, when this parent compound treated with alcoholic zinc and heated, alcoholic zinc, and if it heated, it gives also alkene. Right, students? Another example, say vicinal dihalide. Another example, vicinal dihalide. CH2, say this is a twice CH2Br and CH2Br. When treated with magnesium in dry ether. What is the compound we will get? CH2 twice CH2. Right, students? How? The intermediate, what is the intermediate here? CH2 twice CH2 MgBr and CH2Br. Like the previous example, CH2 twice and CH2, and this is CH2. This is a cycloalkane compound. Right, students? Next, preparation of alcohols. preparation of alcohol. When aldehydes or ketones treated with Grignard's reagent. Already we discussed Grignard reagent always supply one alkyl group to the carbon containing oxygen or nitrogen. Here our group is oxygen, so and simply change this into OH group, but I am going to show you the mechanism also, right? So here this one, this attacks OMgBr. This one hydrolysis it gives or secondary alcohol. Always whenever a ketone reacted with a Grignard reagent or aldehyde, any aldehyde reacted with a Grignard reagent, the carbon number is increased by 1 degree and we will get always the alcohols. If it is a formaldehyde, then we will get primary alcohol. If we use aldehyde, then we will get secondary alcohol. If we take the ketone, then the product is the tertiary alcohol, which I have already discussed in my reels. In my shorts, which I have already discussed in my shorts. Now coming to another preparation, that is from cyanides. How to prepare from cyanides? When say alkyl cyanide reacted with Grignard's reagent. As previously told, always remember Grignard reagent supply one alkyl group to the compound carbon containing either nitrogen or oxygen. Right, students? Now the product is here OH goes with this one and hydrogen goes with nitrogen, so you get the MgBrOH. Right, students? This but on further hydrolysis, this is an imine product is formed, but you don't stop here in exams, so it further hydrolysis, it gives you a ketone. Ketone plus NH3. Ketone plus NH3. Right, students? The mechanism here is, what is the mechanism here takes place? This, when the mechanism here is R prime double bond NH when treated with water. When treated with water, then this is a partial positive, partial negative. So OH minus attacks this carbon and a addition product form like this one, OH and NH2. Now the bond between oxygen and hydrogen. Now the bond between oxygen and hydrogen, here it break like this, and this one, this bond shift takes place, and we will get the product like RC double bond O R prime plus NH3, as I show in the above one. Right, students? This is the simply, what is the trick here? What is the trick here? C double bond triple bond N changes into C double bond O, and degree of carbon increase by 1. This is the one preparation. Another preparation coming to this one, that is esters plus Grignard reagents. What is the product? Now coming to say R C double bond O O R prime. When reacted with a Grignard reagent, let the Grignard reagent I represent here is R. Here alkyl group is R double prime. Then we will get now here bond shift takes place and this R prime attacks this one, that is here oxygen, and the R double prime OMG Br and this is our OR prime. This one hydrolysis give rise to R C OH R double prime O R prime plus Mg Br OH. Now what is this product? Now coming to R C H and R prime O. What is the product here? I think here I have put R double prime and this is O R prime. Here what happens, students? This bond shifts to this one and this to this one, and the further product is, our product is R double prime plus R prime OH. Alcohol and ketone, two products are formed here. Remember this, here the group, one group is the alkyl group is of the carbon, and the group, another R double prime group is supplied by the Grignard's reagent. Here students, we observe that one R double prime is the group supplied by Grignard reagent, right students? So we get the two products. That means whenever esters reacted with Grignard reagent, we get ketones as well as alcohols. Now let us check our concept. How much we are understanding now. Check concepts. Now let us coming to the concept. So here RMgBr when treated with this carboxylic acid, and this is an acetylene group. Students, I have already told that if an acidic proton is there, simply nothing to do. If you want to understand the concept, write alkane. This R, take R from this Grignard reagent and put the protic proton here. Okay. Similarly, here the acidic proton is here, so simply take the alkyl group from Grignard reagent and acidic proton here. That means you always get alkane. Similarly, here what I have given, always see it carefully. It is given magnesium in dry ether, no acidification or acidic media is given, or water is given, hydrolysis is not given. In that case, simply as I have already discussed the mechanism, that is why simply you remove this bromine, take this bromine like this. This is a trick, and you can write like this. This is CH2 double bond CH2. Right students? And coming to aldehydes, this is the aldehyde. So what I have told, our trick is that simply add this group to this one, this alkyl group to this carbon, and change this O into OH group. That means simply what you have to do, like add this group to here CH2 and simply change the oxygen into aldehyde group. And your hydrogen is as usual here. Right student? Now coming to this one, what I have told in this case, the simple trick is that add this alkyl group to this parent carbon and change this C triple bond N into CO. You can do it in fraction of seconds. So here C6H5 and double bond O. Replace C triple bond with double bond O. And coming to this one, as I have already told, when esters are reacted with the Grignard reagent, you will get a ketone as well as an alcohol. Okay, so simply as usual, as I have already discussed, this alkyl group shifted to this parent carbon. So simply write like this. Nothing to do is just add this one, and you already got the a ketone and remaining is an alcoholic agent because if hydrolysis is given, that is why you can write this like and an alcoholic group and unalcoholic group. Students, I think you have understand this concept. You have any other questions, you please comment me. I will try to rectify clear your comments. Thank you students. If you have any doubts, please comment me on the comment box. I will try to solve your question as soon as possible. Right students, for further such a topics, you subscribe my channel and we will meet in the next video with other concept. Thank you.